Okay, and before we go into inserting the query, the one thing we have to add is a replace function, because if we have a single quote within this title or maybe description, that it could screw all of this query up. So we have to replace a single quote by backslash and a single quote. So we need 3 backslashes because actually first one is escaping the second one, and then the third one is escaping the actual single quote. If you are really interested in what this does, you can go ahead into Google and read about element escaping in programming languages, especially in Java. So here we are doing the same, 3 backslashes and a single quote. So we have this query ready, I think. Going back to the movie maker, this URL is based on how large is the movie list. So we can't use that anymore if we are having this list cleared every time. We could actually add to this list or to the total number or something, but what we could do is just not take the list size, but just page times 50, because we know that there are 50 elements in one page, and then add 1 because we want to start from the next one. If we have 100 elements within 2 pages, we want to start from 101st. So we have save movies from page. We are replacing bad elements, substring it. We have the query, everything's fine, so I think we are ready to run it. Let's see what's going to happen. There's a read page number 1. I think we should add some progress printouts within one page because it's taking a lot of time. We have inserted all the movies and there was no exception, so that's good. We are reading page 2 now. I think it takes quite a lot of time because we are downloading the images as well, or trying to download them. Inserted another 50 movies and then the program ended. So we can actually say maybe here, this out, page number page is done. And when we finish, we can say, so we don't miss it, done. Okay. So we read 2 pages. We can go into the database, refresh it. We can see we have 100 rows total. We have a 100 movies inserted, so everything's fine in here. As we can see, there's a movie title with this single quote. So on this one, for example, the query would have an exception because the single quote would be accepted as the end of the one string, and then the query wouldn't understand what's going on. It would have way too many single quotes. So the movie insertion is working really well right now. What I would like to do is create a total architecture of what we want to actually create in the database and how we would like to save all of this. So we will have one table called movie. Let's have it short. This one is actor. And the third one is genre. It would be pretty simple if we would just need three tables and that's it. This would have ID, IMDB ID, and let's say title and something else, right? Actually, the genre has pretty much the same thing, except it doesn't have anything besides the title. Oh no, actually, its IMDB ID is the title, so we can say ID and then the title, and the actor has ID, IMDB ID, and then the name and something else, and other columns, right? So back in Java, when we were working with lists and hash maps, we had these relations between movies and actors. In here, we cannot add all the actors to the movie database table because in the databases it doesn't work like that. What we have to do is create another two relation tables. One we would call movie actor relation, and the other one would be movie and genre relation. And in there, we will just create a relation between movie IMDB ID. This record would also have its own ID identification, and then actor IMDB ID. We're not going to use their actual IDs because we want to be able to create new relations between them without knowing what kind of IDs we have in our own database. So we are able to create new relations without looking into the database. So here it's pretty much the same. Movie IMDB data ID and genre IMDB ID, which is not going to be ID, which is going to be genre title. And so these would be, if you know how this works, each movie can be here multiple times, and each actor can be also there multiple times. I know it's not the best way how to draw this, but this is just to show you just the basics. And in this table, oh, it's not the actor, it's actually the IMDb ID, and so on. So to understand it, I'll draw a little example on the side. Let's work with, where is it? Let's have a movies. It would be, again, let's go with Titanic, Bad Boys. The Titanic, let's, for simplicity, have it at 1. Bad Boys will have ID number 2, and 3 is whatever, Madagascar, right? And then we have genres. Genre number 1 will be comedy. We'll have actors because genres will have the titles. Let's say Leonardo DiCaprio. Number 2 is Chris Pratt. Number 3 was, let's say, Kevin Hart. Okay, and then in the movie genre relations, we will just have a list of these relations. Let's say in the Titanic, we had only Leonardo DiCaprio. So this is a elements ID, the movies ID, and then the actor ID. Then the next relation we have in the Bad Boys, we had, let's say, Leonardo DiCaprio. These are not genres, these are actors. And this is movie actor relations. So the next relation, what we have is in the movie Bad Boys, we also had Chris Pratt. Next relation we have in the movie Madagascar, we had, let's say, Chris Pratt, and in the movie Madagascar, we also had Kevin Hart. Right? So this is how we create these many-to-many relations when many movies can be linked to many actors and vice versa. So in here we can see that if these are the movie titles, the movie IDs, and these are the actor IDs, so we can see movie one had one actor number 1, so this is Leo was connected to Titanic. Movie number 2 had actors number 1 and 2, so Bad Boys had Leo and Chris Pratt, and movie number 3 had actor number 2 and 3. So Madagascar had Chris Pratt and Kevin Hart. So this is the way how we're going to save everything in the database. So these 5 tables will be what we will be having, what we'll be creating, and from which we will create those Java objects back from the database. So right now we have the movie database table. We have to create actor and genre and save both of those as well. And after that, we'll move on to these relation tables. So we can go into the database, create new table, call it table actors. Yes, table actors. Just make sure that I'm recording. And go back to when we need to actually go to the Java class where we have actor name, IMDB ID, and profile URL. Awesome. So there's an ID, IMDB ID, name, and profile URL. ID is integer, unsigned, not allowing null, auto increment, primary key. IMDB is unique, not allowing null, no default values, which is a varchar. Name is also, profile URL is the same. We'll have it at 500 of this, and let's say 100, because I'm not sure that 50 might work with everyone. Will not allow null, but default values will be empty text. And here as well. Save it, everything's fine. Okay, now we can create a new one, table called table genres. What did that have? Just the title and IMDB ID, just the ID, which is again unsigned, without null, and being auto incremented, and primary key. And then just the title, that is a varchar. Yep, 50 I think is enough. Default value is, we will not have default value, and this is this unique identifier, the name of the genre. Okay, so we have all 3 of them. Everything is fine, so we can now try to, well, the first thing we have to do is take the create code, copy it, go into here, take this, create table if not exists, copy, and then go into our database and add these queries. So string actor query is this. It had a new line at the end, and we don't need those ones. Okay, it's all fine. And then this, insert the a query, and then string genre query equals something, and then I'll say this, insert the genre query, and that is from genre table, create code, create table if not exists, and paste it in here. So we could actually delete all of these tables from the database, and next time when we run this program, it would create these tables at the beginning. So this will call the movie query. Okay, we created all the tables. Everything is good in that section. What is the next we have to do? We have to save the genres and the actors as well. So go back to Movie Maker. At the end of this one, we have to work with these actor maps and genre maps as well. But in here, we don't actually need maps. We can just have a list of all these elements. Although we can work with map, because in here we can see that we will not repeat these elements in there as well. So we are within one page, we'll be sure that we are not repeating the elements, the actors and genres. So in here we can actually say save actors from page and save genres from page. Actor map and genre map. And here we want to say this actor map clear and this genre map also clear. We might actually try to save everything in the database after we have read everything, but what if something breaks? We try to read 10,000 pages and something breaks on the 9,000 page. We wouldn't have anything saved for us if something breaks in the middle. That's why I want to save everything for each page, so we are making sure that we have something, right? We do not lose everything. So we will copy this method. Here we will not have an array list, but we will have a hash map of string and actor. Remove that. Here we will be looping through a actor names in the actors key set, and then actor A equals actors get by the actor name. And then this one can be deleted. Everything here is the same. We're inserting objects in there. Insert into table actors. And then we are populating the string part a little bit different. And this one will be different as well. So if we go back to actor, we can see name, IMDB ID, and profile URL. A lot easier for this one. So name, IMDB ID, which is in the database. We don't need to look at what we have in here as the name, as we are passing this one through to actual database. So actors, we have to look actually in here, IMDB ID, name, and profile URL. We can pass them in different order than we have them in here. We need them to be in the same order at the beginning of the query as we have them in each of the actors row. So name, IMDB ID, and profile URL. We can actually have this one in here. It's not that long, we don't need to separate them in two parts. So then this part is, the name is a string, it's in single quotes. Also have a actor dot name, and maybe we'll replace this one as well because some actors might have a single quote somewhere in the name, like oh she or something like that. Then this one, then comma, IMDB ID is also a string. actor, IMDB ID, and then profile URL is string as well. So we'll be having actor, then profile URL, and then comma at the end of this. Then we can copy this one and do the same thing for genres. Mouth of string and genre. This is a genre object. Genres. And this will be a G. And genre has just a title and it doesn't have an IMDB ID. Okay, so really just a title, genre ID and a title. So we're just inserting into table genres, just inserting title, and we say g.title. There's the problem, there's no problem. Okay, then we skip this and insert this one. So on each page that we are reading, we are taking all the movies, putting them in the list, actors in the list, and genres in the list. We take all these lists, give them to database. Database loops through all of these lists, creates insert query for each of them, tries to insert everything in the database. If we have some of them already, we are recognizing them genres by its title, actors by IMDB ID, and movies also by IMDB ID. If it has it in the database, it's not creating a new one. If it doesn't have it, creates a new record from it in the database. We can actually delete some movies. Okay, let's not delete the movies and see what we are dealing with. If we try to insert, let's say, those same two rows, two pages. Try to insert all three of them, movies, actors, and genres. And the same for page 2, and everything is done. If we go to here, we can see if we refresh it, we still have these 100 rows because all of those were already here by this ID. If we go to the genres, we see that we have new genres, and the actors as well. We have a lot of actors in here. These reference IDs doesn't matter. We can still have them. Right, so we have 363 actors, 18 genres, and 100 movies for first 2 pages. So the next thing what we have to do is create these relations, okay? So how can we do that? When we save these movies, for each movie, if we go back to where's the movie class, we have a list of all the actors in all their genres. So before we go back here, we could actually save the actors and genres at first, and then save the movies, the last ones. It doesn't actually change much, but it will be better. Once we save these movies, we can actually go through and create an insert query for each movie, for each of its genres. If we go back here, just as an actors, let's say Titanic had an array list in which it had this actor Leonardo DiCaprio object. So it had, let's say, an ID of 1. The Bad Boys had an array list of 2 objects, number 1 and number 2. These are actually genre objects, but it had no actor objects, but they had their own IDs. So what we have to do is for each movie, loop through all of these objects and say, okay, movie number, the movie that we have, create a relation for this movie that we have, and loop through all the genres, all the actors and genres, and take their relation ID and create a new relation. So if we go through with it, I think it might be easier to understand. Let's create a new table. We'll call it relation. You can also call it a table. I like to call it relation as it's something in between. It's not actually a simple table. So relation movie actor. And then here it has its own ID, unsigned, not null, primary key just to have it an ID. And here we will have movie IMDB ID, which is not going to be unique in here because one movie can have multiple records in here. It's not an integer, it's a varchar. And we add, and what is it? If it's the basic relation movie actor, then this has to be an actor IMDB ID. Also varchar, it cannot have a, this will be actually auto increment, and these two will not have a default values because they cannot be empty. Each record has to have one of those. We save it, everything's fine. Let's create the other relation for relation movie genre. Okay, same thing, ID, unsigned, allow, auto increment, primary key, then movie IMDB ID. And then the other one will be genre title, as that is the thing that genre has that is unique. Also no default, don't allow null, nothing, we can save it there. Also, let's have a create query, steal that, and save these tables as well. Create table if not exists. Go back to our database, and here movie actor relations. And then movie genre relations as well. This, no, we need a string at first. Relation movie genre is something. And then this, insert the relation mg. That one will be the other table. Wait, what did I copy? No, this is mg. Although it wouldn't change much, but just so we know, this was genre, and these will be actors. This is table actor. Okay, that's fine. We can remove these, and we create all these tables. And now when we go through the save movies from page, what we have to do is create also a string relation movie actor query. We can say that is insert, also ignore, although we do not need to create ignore because we cannot have any problems in here. If we create a relation one more time, that's not a problem in this one. Into table, not movies, not table, actually relation. What was it called? The movie actor, relation movie actor. And here we will have a movie IMDb ID and actor IMDb ID. And then for each movie, we'll loop through all of its actors. In this movie's actors, and we will add to relation MA query what we need to add, the movie's IMDb ID, which is a string, so it's this movie's IMDb ID, and then the actor's IMDb ID. So for this actor IMDb ID. So we do that for all the movies and all the actors. And at the end, we just do the same thing to this query. Remove the last comma, print it maybe, insert it, and do the same thing for all the genres as well. Genre G, movie genres, then movie ID, and then the genre title is what we need. And this will have another query, MG, movie genre, then it has movie IMDb ID, and what did I call it? Genre title. And then movie and genre title, what we have to do the same stripping there as we did before. MG query, MG query. We have to separate them so we understand where one starts and one ends. So this one is in here. So I hope it works. Let's try with one page at first. We could actually delete everything. Oh, what? Just empty table. Empty tables, just so we can see the difference, what is made. And then we can run it. Reading the page, everything's fine. And we have a problem. Insert into something something. We had problems with a couple of queries. Okay, let's try to work out what was wrong. Shift and copy it, and let's paste it in the Heidi so we can see what was wrong. Oh, we needed values, right? Print these things and then the actual values of those and those and those. Database, yes, here values, and the ones I would insert, and the values, the ones I would insert. Yeah, and then this is the stack trace of an error. Yeah, both of them, or actually all of them, actually failed for this row. We can actually, what we can do is cheat a little bit just to see if everything would work. You just copy it back in and see if it works. We run it. Affected rows 200, so great, we created that. And for the genre, shift and copy and paste again, and here values. Okay, we can run it. Affected rows 115. So we can go to this. So we can see here that, let's say for which movie? This movie, it nicely selects all of these which have the same ID. We have IDs of 4 actors. So for this movie, we have also 4 actors. This movie also 4 actors. So from here, we can connect to the other table to find the actual actors for each movie. If we see the actors, we have 191 rows, genres still 14, and movies 50 for the first row. Okay, so what I'm going to do before we go to the next part, which will be retrieving all the data actually into the our application, I'm going to set this one to a, let's try 200 or 500. Okay, let's try 500. I'll leave those. And what I'm going to do is I'm going to run this one and have the results ready for the next part where we will be attacking the data read from the database. So what you can do in preparation to the next one is also run it for 500 or whatever, at least 10 pages, so you have some kind of data. So in the next video, we'll be working on the second part, which I removed from this. Maybe we can get it back. No, we can't. Pine's history doesn't go back that far. So we had the web, we had our application, and we had the database. So we asked for the web, asked the web for the data, got everything back. Now we put everything in the database. So only thing that's missing is putting all of the data in our application. So that's what we'll be doing in the next video.